Good day. We'll have some additional examples on the basic properties of logarithm. The first part of the examples, or the link for the first part of the examples, is posted on the description box. So let's have this review first for our three basic properties of logarithm. Our b is our base. So let b and x be real numbers such that our base is positive and base is not equal to 1. Then the three holds. The first one says that log of 1 for any base b, the result is always 0. This is also applicable to natural logarithm. So ln of 1 is also equal to 0. Okay, number 2, log of b raised to x base b is equal to x. So the same thing in the natural logarithm. ln e raised to x is equal to x. Okay, because take note that ln is just the log base e. So we can rewrite this one as log of ex base e. So that is equal to x. And last, if x is positive, then this expression is equal to x. Okay, so our focus for this discussion is on number 2. It's more on number 2 because that's what I've said. Number 1, log of 1 for any base b is always 0. And for number 3, we rarely have this expression. So most of the time, we have number 2. Okay, so use the basic properties of logarithms. And of course, we'll compare this one to exponential form to find the value of the following expressions. So we have these 5 problems or 5 logarithmic expressions. So let's start with number 1. So log of 10,000. Take note, we have no base written here. It means that our base is 10. Okay, our base is automatically 10. If it is not written, then the base is 10. So we have here first, let's start with the basic properties. Log 10,000. Now, 10,000 can be written as 10 raised to 4. Okay, 10 raised to 4. So with our property number 2, that if we have this log of b raised to x, the result is x. So we have two bases. If they are the same, then the result is x. Take note, our base here is again 10. So we have log of 10 raised to 4 base 10. So we can now apply this 1. So this means that this is equal to what? This is equal to 4. If you want to use the exponential, so we'll just equate this given into x and then convert this one to exponential form. So take note, we'll start with b base raised to x equals 10,000. Okay, recall that if we have log of b base, log of a base b is equal to c, then we can always rewrite this one in exponential form. We'll start with the base raised to this one, c equals a. Okay, so that's what happened here. So 10, so our base here is 10, so we have 10 raised to our c is x, and we have our a is 10,000. Okay, so that's why we have this. 10 raised to x equals 10,000. And then let's apply the solving part for exponential equation. So 10,000 is again 10 raised to 4. By 1-to-1 property, because we have now the same base, which is 10, so x is equal to 4. Okay, x is equal to 4. Therefore, we can substitute now the value of 4 here. So therefore, log of 10,000 is equal to 4. So both strategy have the same answer. Next, we have this log of 1 over 81 base 9. So we can rewrite 81 as 9 squared. That is our goal because our base is 9. So as much as possible, the other numbers must be in terms of the base. Now, if we take the reciprocal, that will become 9 raised to negative 2. And again, this is equal to negative 2 because of property number 2. Log, please memorize or familiarize. Log of b raised to x base b is always equal to x. So we have now b, our base here is 9. Our exponent x is negative 2. Therefore, the result is negative 2. Again, let's compare it to exponential form. Equate the given to x. And then we have the base raised to x. So 9 raised to x is equal to 1 over 81. But 1 over 81 is equal to 1 over 9 squared. Okay, this is 1 over 81. So 81 is 9 squared. So again, let's take the reciprocal, 9 raised to negative 2. And then by 1-to-1 property, so we have the same base 9. So therefore, x is equal to negative 2. So therefore, the result for this one is negative 2. Number 3, log of 4 base 16. Take note that our base is 16, so we can rewrite 4 in terms of 16. 4 is just the square root of, uh, 4 is the square root of 16. Okay, this is just the square root of 16. Okay, square root of 16. And take note, when we have square root, that is, our exponent is 1 over 2. Okay, so therefore, this 1 over 2 here is an exponent. So 1/2. Okay, 1/2. So now we have BB, our base is 16. So applying property number 2, the result is 1/2. Okay, let's compare this to exponential. So equate this one to x. And then we can rewrite this one into exponential form. 16x. 16 raised to x equals 4. Okay, and 16 can be written as 4 squared. So 4 squared times x as an exponent. So 2 times x. So we have 2x. So by 1-to-1 property, we have now 2x is equal to 1. Take note there is a 1 there. 4 raised to 1. So 2x is equal to 1. Divide both sides by 2. So x is equal to 1/2. So again, they have the same answer. 1/2. Number 4, we have this. So the base is a fraction, positive 3/4. So take note that 16 and 9 can be written as 4 squared and 3 squared. By the property of exponents, we can rewrite this one as, okay, these two are just the same. We can rewrite this one as this, the square of 4/3. So we can factor out the common exponent. And then we have the reciprocal. So the exponent will be negative 2. So from 4/3, it becomes 3 over 4. So from b, log of b raised to x base b, the result is the exponent. So this is actually equal to negative 2. Okay, negative 2. So let's compare this one to exponential. So 3 raised to 4 raised to x is equal to 16 over 9. Again, 16 over 9, we have 4 squared over 3 squared. So we can factor out the common exponent and then reciprocate or take the reciprocal. So we have negative 2. The exponent here is negative 2. By 1-to-1 property, x is equal to negative 2. So we have the same answer. And last example, number 5. So the base is 1/4. So take note that 2 is a square root of 4. Okay, square root of 4. But here we cannot apply the second property because 1/4 is different from 4. So in order for us to apply that one, we need to take the reciprocal of 4, which is 1/4. So the sign of 1/2 will become negative 1/2. Take note, half 4 is equal to 4 over 1. Okay, so we have 1/4. So and then the exponent is negative 1/2. So we can now apply the property number 2, log of bx raised to b equals x. So therefore, this is equal to the exponent negative 1/2. And for the exponential, we can write this one in exponential form. 1/4 raised to x equals 2. And 4 is 2 squared. If we take the reciprocal, we have negative 2 or 2 raised to negative 2x by power to power rule. Okay, so this is 2. This is still 2. Okay, and then by 1-to-1 property, they have the same base. So this is 2. So 2. The exponent of 2 here is 1. So that is why we have the exponent negative 2x equals 1. And dividing both sides by negative 2. Okay, negative 2. Therefore, x is equal to negative 1/2. So therefore, the result of this is negative 1/2. So they have the same answer. Thank you for listening.